Tonight, as you settle into the quiet of your room, you're drifting through a galaxy that is anything but quiet. The Milky Way looks calm from here, just a soft river of starlight across the sky. But the truth is far more compelling. Right now, at this exact moment, our galaxy is tearing smaller galaxies apart, pulling stars across tens of thousands of light years and sending shock waves through its spiral arms. You are moving through this restless structure at more than 500,000 miles per hour, and yet you feel nothing. No wind, no rumble, just stillness. That contrast, the peace you feel versus the wild motion you're inside, is the perfect starting point for tonight's journey. You clicked this video because you wanted balance, a little knowledge, a little calm, something to expand your mind without overwhelming it, something steady to fall asleep to. And in that spirit, let me offer you a simple promise. Tonight, you'll hear 100 quiet facts about the Milky Way. Facts that are strange, beautiful, sometimes shocking, but always gentle. Facts that help you understand the home you've been traveling through your entire life. Let's begin with an idea that might surprise you. Some of the stars you can see tonight are older than the Milky Way itself. That's real. Our galaxy wasn't born all at once. It grew by consuming smaller galaxies, gathering stars, pulling in streams of ancient light. And you're living inside the end result, a cosmic mosaic assembled over billions of years. A galaxy built not from peaceful formation, but from mergers, collisions, and long-forgotten encounters. Understanding that is the doorway into understanding everything else. And here's another quiet truth. You've never actually seen the Milky Way. Not the whole thing. Not even close. You've only ever seen it from the inside, through clouds of dust that block most of the structure from view. It's like trying to draw a map of your entire house while locked inside the hallway. Every detail we know, every arm, every cluster, every measurement, comes from light filtered through dust, from motions tracked across decades, from the faint wobble of stars thousands of light years away. We're mapping our home from the inside, with patience and clues. Tonight, you'll explore all of that. Softly, slowly, at a pace meant not to excite you, but to ease you toward rest. You'll drift from the galactic center, where a 4 million solar mass black hole sits quietly, to the spiral arms where new stars are born. You'll float out to the halo, where ghostly streams trace the remains of galaxies long gone. You'll pass by rogue planets, wandering alone in the dark. You'll travel through magnetic fields that curve like invisible rivers, and through the thin ocean of gas that fills the space between stars. You'll step back far enough to see our place in the local group, our small island of galaxies drifting together through the universe. And you'll learn something deeper. The Milky Way is not a picture. It's a living, moving system. Every star, every cloud, every planet is in motion. Every orbit is different. Nothing is still. The galaxy breathes in cycles millions of years long. And yet inside all that motion, you get to rest. Tonight isn't about memorizing facts. It's about letting them wash over you, one by one, like soft waves. You'll hear how the arms of the galaxy aren't solid structures, but density waves, traffic jams made of stars. You'll hear how the sun has orbited the galaxy only 20 times since Earth formed. You'll hear how Andromeda is drifting toward us, slowly, silently, in a dance that won't complete for billions of years. You'll hear how the elements in your blood were forged in ancient explosions that once shook the very gas you're drifting through now. These aren't loud facts. They're quiet realizations, pieces of a puzzle that help you feel grounded, connected, and small in a way that comforts rather than frightens. Because the deeper truth is simple. You are part of this galaxy. Not just living inside it, but made of it. Every atom of your body came from stars that lived and died long before the sun. You're a continuation of cosmic history, shaped into a human perspective, one that can lean back, close its eyes, and listen to the story of home. So take a breath. Let your shoulders soften. Let your thoughts unclench. Tonight, you and the Milky Way are moving together, quietly, through the dark. And now, let's begin. When you picture a galaxy, you might imagine something serene, a great pinwheel of stars drifting gently in the dark. But the Milky Way you live in was not shaped by peace. It was built by impact, by gravity tearing smaller galaxies apart, by encounters that stirred its structure and rewrote its future. Tonight, as you rest, the quiet sky above you hides a history of violence so ancient and so vast that it defies comparison to anything on Earth. And understanding this history helps you understand why the Milky Way looks the way it does, why it moves the way it moves, and why certain stars around you don't even belong to this place. They're guests, survivors, remnants of collisions that began before the sun was even born. The story begins with the Milky Way in its youth. Smaller, rougher, not yet the grand spiral you know. It grew by pulling in the faint dwarfs that wandered too close, stretching them apart until their stars spilled into long, thin streams. These streams still wrap around the galaxy today, like ghostly ribbons, drifting so slowly across the sky that only deep surveys can reveal them. They are the scars of ancient encounters, the evidence that your galaxy was shaped by hunger. As astronomer Alvio Renzini once said, galaxies grow by devouring their neighbors. The Milky Way is no exception. You don't need to imagine these collisions. One is happening right now. The Sagittarius dwarf galaxy, a fragile, elliptical companion, is currently being torn apart. Its stars are being pulled into an arc that loops around the Milky Way, forming a tidal stream that takes hundreds of millions of years to complete a single wrap. You can picture it as a faint trail of stardust left behind by something too small to defend itself. And even though the Sagittarius dwarf is disappearing, its stars will remain here for the rest of cosmic time, integrated into the halo that surrounds the galaxy, moving on orbits that tell scientists exactly where they came from. The halo itself is one of the most revealing regions of the Milky Way. It's not bright like the spiral arms. It's not dense like the central bulge. Instead, it's a faint, spherical cloud of ancient stars that circle far above and below the plane of the disk. Many of these stars are older than the Milky Way itself, more than 13 billion years old. Just think about that for a moment. Some of the stars you might see through a telescope tonight were burning long before the Milky Way even completed its first form. Their chemical fingerprints show almost no heavy elements, meaning they were born when the universe was still young and simple. These stars didn't originate here. They were brought in, collected, captured through collisions the Milky Way has long since forgotten, but still carries within its structure. One such event was the Gaia-Enceladus merger, an ancient cosmic collision with a galaxy that once wandered too close. The evidence is written in the motions of stars, in the way they travel on elongated chaotic paths that differ from the smooth rotation of the Milky Way's disk. When scientists mapped these orbits, they uncovered a story of a small galaxy being absorbed billions of years ago, a story preserved not in text, but in the movement of stars that survived the impact. You live in a galaxy that remembers through motion. And these moments of growth through collision never fully stopped. Even today, you're living in a galaxy that is preparing for its next great transformation. Far out in the dark between galaxies, the Great Andromeda Spiral is moving toward the Milky Way at about 110 kilometers per second. It's still 4.5 billion years away, but on the scale of cosmic history, that's not long. When the two galaxies finally meet, their stars will pass through each other like dust through mist. Gravity will reshape both into something new, larger, rounder, calmer. And long after Earth has changed beyond recognition, this future galaxy will carry traces of both current spirals, just as the Milky Way carries the stories of galaxies it consumed long ago. When you hear all this, you might expect something chaotic, something turbulent, but the truth is quieter, more thoughtful. These collisions happen over hundreds of millions of years. They take longer than life on Earth has existed. They shape the galaxy not through sudden explosions, but through slow stretching, gentle unraveling, and steady gravitational pull. The result is a structure made of pieces from everywhere. Stars born here, stars born elsewhere, stars older than the galaxy, stars young enough to have formed when dinosaurs walked the Earth. You are living in a composite, a tapestry woven from countless origins. And knowing this changes the way you think about your home in the cosmos. The Milky Way isn't a single unified object. It's a collection of stories layered over one another. Every time you look at the sky, you're seeing the aftermath of collisions that shaped your world without ever touching it. You're seeing the long memory of a galaxy that has survived impact after impact, gathering strength and structure each time. You're seeing pieces of other galaxies that once had their own histories, their own shapes, their own quiet nights, before being folded into this one. And so the question naturally emerges: if all this merging, tearing, swallowing, and absorbing has been happening for billions of years, where does the sun fit into this story? What role does your solar system play inside a structure built by collisions? The answer begins with motion. Your motion, the sun's motion, and the path you've been following for as long as Earth has existed. You spend your entire life feeling rooted to one place. Your home, your city, your favorite chair at the end of the day. All of it feels steady, fixed, and unmoving. But the truth is far stranger and far more beautiful. You have never been still. Not for a single moment. From the day Earth first formed, you've been riding on a world that's not just circling the sun, but circling the entire Milky Way, completing a journey so vast that your mind almost refuses to picture it. This is your real orbit. This is the path you travel without ever noticing it. A single lap around the Milky Way takes about 225 to 250 million years. Scientists call it a galactic year, and every living thing that has ever existed on Earth has lived entirely inside a small fraction of one. When the first forests covered the continents, Earth was in a different part of the galaxy. When dinosaurs roared across ancient plains, the solar system was somewhere else entirely. When the first humans stood upright and looked at the stars with curiosity, the sun was thousands of light years away from the place it occupied during the age of reptiles. In all of human history, not centuries, not millennia, but the entire span we've been writing, building, inventing, and dreaming. Earth has never been in the same place twice. You've been moving through the galaxy the way a boat moves along a river, pushed by forces older than time itself. And yet, you feel none of it. The sun carries you around the galaxy at about 230 kilometers per second, fast enough to cross the United States in the time it takes to drink a cup of coffee. But you don't feel any wind. You don't feel any shaking or rattling beneath your feet. The reason is simple. Everything around you is coming along for the ride. Every star you see, every planet, every grain of dust, the entire solar system is moving together like a calm caravan drifting through a dark wilderness. You're traveling at a speed that should be overwhelming, but it feels like stillness because nothing around you resists the motion. Think about what that means for a moment. The galaxies you see in photographs often look frozen, pinwheels of light holding their shape for eons. But the Milky Way isn't a solid structure. It isn't a rigid wheel turning in place. It's a living flow of billions of stars, each one orbiting the center at its own pace. Some move faster, some slower. Some rise above the galactic plane, others dip below it. And because of these differences, the arms of the Milky Way aren't fixed objects. They're patterns. They're waves of density, places where stars temporarily gather as they pass through, like cars slowing down in traffic. If you look at them from far away, you see a beautiful spiral. But if you were to float inside it, you'd realize the arms are never the same from one galactic year to the next. They're not material structures. They're rhythms. And you're moving through these rhythms right now. Your solar system has crossed spiral arms, drifted between them, and passed through regions of star formation where brilliant young suns ignite. It has also traveled through quieter regions where older stars live out their long, steady lives. All the while, gravity pulls you gently toward the center of the galaxy, guiding you along a curve so immense that it takes hundreds of millions of years to return to where you started. If you could ever truly define such a place in a structure that's constantly changing, when you imagine this journey, it does something unexpected. It doesn't make you feel small. It makes you feel connected. You're not simply living in a house or a city or a country. You're living inside a system that is traveling through the galaxy, carrying with it the entire history of Earth. Every creature, every civilization, every memory. You're part of a vast migration, one that began long before humans appeared, and will continue long after the last trace of humanity fades. You are a passenger on a world that has seen the galaxy from more angles than you can count. And even more humbling, the path you're on is not unique. Every star in the sky is following its own orbit, shaped by its mass, its distance from the center, and the invisible currents of the galaxy. Everything is in motion. Everything is part of this quiet, slow dance. As Neil deGrasse Tyson once said, we are voyagers on a 250 million year orbit. It's a simple sentence, but tonight it's your reminder that the universe never stands still, and neither do you. So where are you in this moment? Where, inside this moving structure, does your solar system sit? To understand that, you need to step back even further and look at the shape, the layers, and the hidden framework of the Milky Way itself. You need to see the house you're orbiting inside, not from Earth, but from a perspective wide enough to reveal its structure. You've spent your life seeing illustrations of the Milky Way. Clean spirals, smooth arms, perfect symmetry. But those drawings were never meant to be literal. They're closer to maps of an unfamiliar country than photographs of a place you've actually seen. The real Milky Way is far more complex, far more dynamic, and far more difficult to understand than any simple spiral sketch. And the biggest reason is this: you're trying to understand the shape of the galaxy while living deep inside it. It's like trying to sketch an entire house while standing in the living room. Walls block your view. Light bends around corners. Dust hangs in the air. You can measure, you can infer, you can guess, but you can never truly step outside to take a single clean look. Everything we know about the galaxy comes from signals collected through dust, models built from motion, and data stitched together from the faintest hints of what lies beyond our line of sight. That's why the Milky Way's structure feels mysterious. You can't back up far enough to see it. Dust clouds stretch for thousands of light years, blocking visible light and warping the picture. Only by using radio waves, infrared light, and detailed measurements from missions like Gaia can scientists begin to piece together what this galaxy actually looks like. Every new map redraws part of the old one. Every new discovery reveals that a detail once believed to be solid was just a shadow cast by dust. You live in a galaxy that must be imagined before it can be understood. And once you begin to imagine it, the first thing you encounter is the spiral arms. Most people think of them as great whirling blades sweeping through space, but they're not solid structures. They're density waves, patterns, not objects. Think of traffic on a busy highway. Cars keep moving, but slowdowns and speed-ups create long, stretched-out zones of congestion. The spiral arms work the same way. Stars pass into them, linger for a while, then move on. Gas clouds are squeezed as they enter, triggering new star formation, which is why the arms glow with brilliant young blue stars. But these arms can fade, break, twist, or split apart. They're not fixed. Even the number of arms is debated. Some maps show 2 dominant arms. Others show 4. Some suggest combinations that defy simple categorization. You don't live in one of the major arms. You live in a quiet, unassuming neighborhood called the Orion Spur, a small branch between the larger Perseus and Sagittarius arms. From here, the galaxy doesn't feel like a grand spiral. It feels like a crowded field of stars with no obvious pattern. Dust makes it even harder to see the arms clearly, bending starlight and hiding the bright knots where new stellar nurseries form. The structure exists, but from the inside, you can only sense it like a whisper through fog. Move closer to the center of the galaxy, and you discover something even stranger. the galactic bar. Instead of a simple glowing bulb at the core, a thick bar of stars stretches roughly 27,000 light-years across. It rotates, slowly but steadily, at a different speed than the spiral arms. And this rotation controls the flow of gas and stars into the center, shaping how the arms twist outward. From Earth, the bar is tilted at about 20 to 30 degrees, so we see it sideways, slightly skewed. Its slow spin helps define the rhythm of the Milky Way, pulling stars into long, elegant arcs. As Ralph Schoenrich once said, the galactic bar shapes the very flow of the Milky Way. Around that bar lies the bulge, the swollen central region where stars are packed so tightly that night and day would blur together if you could stand on a world inside it. The bulge isn't smooth. It has a peanut shape or an X shape, depending on your angle of view. These forms emerge from stars lifted upward by the bar's motion, creating contours far more intricate than a simple glowing center. Most of the stars here are old, ancient even, burning with a steady dimness that reflects a history stretching back nearly to the birth of the galaxy. And in the very center, hidden behind clouds of dust and gas, lies one of the most remarkable features of all: Sagittarius A, the supermassive black hole. About 4 million times the mass of the Sun, it sits like an anchor around which the entire galaxy rotates. You might expect something so massive to be violent or stormy, but right now it rests in a quiet state, pulling stars into tight, fast orbits without consuming large amounts of material. Those orbits, measured over decades, are the clearest proof we have of the black hole's existence. Stars near the core whip around it at incredible speeds, tracing elegant ellipses through space. And yet, despite this gravity, despite its age, Sagittarius A is calm enough to let the galaxy's story unfold around it without interruption. But the visible parts of the Milky Way tell only a fraction of the story. The rest, the majority, comes from something you cannot see at all: the dark matter halo. The outer regions of the galaxy rotate too quickly to be held together by visible matter alone. By all standard physics, the galaxy should have flung itself apart long ago. The only explanation is an enormous, invisible structure surrounding everything. A halo made of dark matter. It doesn't shine, it doesn't absorb light, and it doesn't interact with normal matter except through gravity. But it accounts for nearly 90% of the Milky Way's mass. As Vera Rubin famously said, dark matter is the invisible skeleton of the galaxy. Without it, the Milky Way would unravel. Then there are the Fermi bubbles, two enormous lobes of gamma radiation stretching roughly 25,000 light-years above and below the center. They're relics of something dramatic, perhaps a burst of activity from the black hole long ago, or powerful winds from clusters of young stars in the core. Whatever caused them, they represent some of the most energetic events in the galaxy's past, rising like giant plumes into the dark. Surrounding all this, the disk of the Milky Way is not flat, despite nearly every textbook drawing suggesting otherwise. It's warped, curving upward in one direction and downward in another, like a vinyl record left in the sun. This warp may come from interactions with the Magellanic Clouds, from long-ago collisions, or from an uneven distribution of dark matter tugging at the disk. And the disk itself has two layers: a thin disk full of young stars, gas, and dust, and a thick disk of older, metal-poor stars whose motions bounce above and below the plane. The thick disk may be the lingering footprint of an ancient impact that lifted entire populations of stars into new orbits. When you step back and take all of this together, the arms, the bar, the bulge, the hidden dark matter skeleton, the warped disk, the glowing bubbles, you realize something profound. The Milky Way isn't a simple spiral. It's a living, evolving structure with currents, flows, pressures, and memories. And even though this galaxy is enormous, your place inside it is steady and safe. You're part of a system that moves with calm, predictable motion, guided by forces far more stable than anything in your daily life. You're not drifting through chaos. You're drifting through order. And understanding this shape is only the first step. Once you know the structure, you can begin to uncover its past. Stories, written not in books, but in the orbits of ancient stars and the streams that stretch across the darkness. When you hear the word halo, you might imagine emptiness, a thin, quiet shell around the Milky Way with nothing much inside it. But the real halo is nothing like that. It's not a void. It's a vast, three-dimensional sphere surrounding the entire disk of the galaxy, reaching far beyond the spiral arms you think of as the Milky Way. It's older, wider, and more mysterious than any other part of the galaxy you've explored so far. And tonight, as you're listening in the calm of your room, you're also drifting inside a structure that holds some of the oldest stars, the faintest memories, and the clearest evidence of how the Milky Way came to be. The halo matters because it holds the history the disk can't keep. The disk is young and busy, full of gas clouds, newborn stars, and bright blue clusters. But the halo is quiet, ancient. It stretches more than 10 times thicker than the visible disk and carries within it stars and clusters that orbit on enormous paths, arcing high above and below the plane. It's a museum of cosmic leftovers, where the Milky Way's earliest chapters are still written, faintly but unmistakably. The halo surrounds you like an old story, whispering pieces of the past through the motions of its stars. One of the clearest clues in that story comes from stellar streams, long, delicate ribbons of stars that wrap around the galaxy. They're stunning once you know how to see them. Arcs stretching tens of thousands of light years, thin as threads, but bright enough to detect when you add up billions of seconds of telescope exposures. These streams form when small galaxies wander too close and are slowly stretched apart by gravity, pulled into trails that continue orbiting long after their original shapes have dissolved. The Sagittarius stream is the most famous example, a long wound left by a dwarf galaxy that is still being torn apart today. Some of its stars have wrapped around the Milky Way several times, tracing elegant loops that scientists can use to measure the mass of the invisible dark matter halo. You may look up and see a calm night sky, but woven into it are the remains of galaxies the Milky Way consumed long before humans existed. Move a little deeper into the halo, and you find some of the most remarkable structures in all of astronomy. The globular clusters. These aren't small groups of stars like the clusters in the disk. Globular clusters are ancient, dense spheres containing hundreds of thousands of stars packed into regions only a few dozen light years wide. Their stars are old, older than the spiral arms, older than many parts of the Milky Way, often 12 to 13 billion years in age. Some formed when the universe itself was still new. They orbit the halo in immense, stretched-out ellipses, like comets on a galactic scale. And many of them may be the surviving cores of dwarf galaxies the Milky Way pulled apart long ago. When you look at a globular cluster through a telescope, you're looking at a fossil. Just as Olin Eggen once said, globular clusters are fossils from the universe's youth. But the halo doesn't just hold clusters. It holds stars that once belonged to galaxies now lost to time. One of the most dramatic examples comes from the Gaia Enceladus event, a major merger that reshaped the Milky Way billions of years before Earth formed. When astronomers mapped the motions and chemistry of hundreds of millions of stars using Gaia data, they uncovered a population with chaotic orbits, low metal content, and a distinctive blue color. Stars that clearly didn't originate here. They were the remnants of a galaxy swallowed whole. Their movements still reveal the violent motions of that long-ago collision, and their presence marks the beginning of the Milky Way's thick disk. When you look at them, you're seeing a scar, one your galaxy will carry forever. And then there are the halo stars that defy almost every expectation. A few of them are so primitive, so chemically simple, that they appear older than the Milky Way itself. Born from nearly pristine material left over after the Big Bang, these stars tell a story the disk cannot. A story of formation before the Milky Way had a name or a shape. Long before spiral arms existed, long before the bar formed, long before the galaxy reached its current size, these stars were already burning. Some stars in the halo were born before the Milky Way existed. It sounds impossible, but the chemistry is unmistakable. Their atoms remember an earlier universe. This is why the halo feels so different from the rest of the galaxy. It's not vibrant or active. It doesn't glow with new formation or swirl with gas clouds. Instead, it hangs around the disk like a quiet witness, watching the galaxy evolve over billions of years. Katherine Johnston captured it perfectly. The halo is a graveyard of galaxies. And yet it's not a sad place. It's a serene one, a landscape where ancient remnants drift slowly, carrying their stories along orbits that take hundreds of millions of years to complete. Listening to this, you might feel something shift inside you, a recognition that the galaxy isn't a single thing. It's a collection, a mosaic of survivors, mergers, fragments, and memories. Every star in the halo is a reminder that the Milky Way didn't grow alone. It collected companions along the way, folded their stars into its structure, and blended their histories into its own. When you look at the sky, you're not just looking at the Milky Way. You're looking at dozens of galaxies long gone, their stars now woven into the fabric of your home. And understanding this changes the way you see the night. You begin to realize that nothing in the galaxy is isolated. Everything you see is part of something older, broader, and more interconnected than it first appears. The halo shows you that growth, even on a cosmic scale, comes from absorbing the past and carrying it forward. But stars are not just relics. They are alive. They're born. They shine. They die. And they shape the galaxy itself. When you look up at the night sky, you see stars as steady points of light. Calm. Unchanging. Almost eternal. But their true lives are anything but still. Stars are born, they grow, they age, they transform, and eventually they return everything they are back to the galaxy. And tonight, as you settle into the quiet of your evening, you're going to drift through that entire cycle, not through equations or diagrams, but through the gentle rhythm of how stars actually live. This is the story that leads, eventually, to you. It all begins inside molecular clouds, vast cold regions of space made mostly of hydrogen. These clouds are enormous, sometimes larger than entire star systems, yet they're so dark and so cold, you could fly straight through one and never know it. Their temperatures hover around 10 Kelvin, just a few degrees above absolute zero. You can imagine them as cosmic winter fields, quiet and motionless. But inside that stillness, something delicate is happening. A passing shockwave from a nearby supernova, or a slight increase in density from the cloud's own internal motions, begins to compress part of the cloud. Slowly, patiently, the gas collapses under its own weight. What begins as an invisible knot of hydrogen grows tighter, denser, and hotter, until it forms the seed of a star. And around it, dozens or hundreds of other seeds begin forming too. Stars are rarely born alone. As the cloud collapses further, it becomes something beautiful, a star nursery. Nebulae like the Orion Nebula or the Carina Nebula are the glowing birthplaces of new suns. Their pink and red light comes from hydrogen gas energized by young hot stars. Within them, newborn stars push outward with powerful stellar winds, carving out bubbles and cavities inside the cloud. It's as if they're clearing space for their own futures, sculpting the nebula into shapes we can now see with telescopes. These nurseries don't just create stars. They create star families. Clusters of siblings are born together, sharing the same cloud, the same chemistry, the same starting point in the galaxy. Once a star ignites, it enters the main sequence, the long, steady middle stretch of life where it burns hydrogen into helium. About 90% of a star's lifetime is spent here. For our sun, this is where it is right now, settled, stable, and quietly shining. It's neither young nor old. It's in what you might gently call its middle age, producing the steady stream of light and warmth that has supported life on Earth for billions of years. And for most stars, this phase is peaceful. They don't flare violently. They don't change dramatically. They simply burn, holding themselves in delicate balance between the inward pull of gravity and the outward pressure of nuclear fusion. But the peace of the main sequence doesn't last forever. For stars much larger than the sun, the end comes with stunning force. When a massive star runs out of nuclear fuel, it can no longer support its own weight. The core collapses almost instantly, and the outer layers rebound in an explosion of incredible power, a supernova. This moment is brief, violent, and essential. It's in these final seconds of a star's life that the heaviest elements are created. Iron, gold, nickel, uranium. Everything heavier than iron was forged in the last breath of stars that lived and died long before Earth formed. Supernovae blast these elements outward, seeding the galaxy with the material needed for planets, oceans, and eventually biological life. The shock waves they produce can compress nearby gas clouds, triggering the next generation of star formation. A supernova is not just an ending. As Norbert Langer said, A supernova is both an ending and a beginning. This recycling of material is one of the most profound truths in astronomy. Every atom in your body, every bit of carbon in your lungs, every calcium atom in your bones, every iron atom in your blood was created inside a star. Some of those atoms came from stars that lived gentle, long lives. Others were thrown into space by ancient supernovae that lit up the galaxy before the sun even existed. When Carl Sagan said, "We are made of star stuff," he wasn't being poetic. He was describing a literal fact of nature. You're not just in the universe. You're made from its ashes. But stars don't live their entire lives alone. Most are born in clusters. Some drift apart over time as gravitational tides pull them away, scattering them across the galaxy. Others stay together for millions of years before they slowly dissolve into the disk. Astronomers sometimes talk about solar siblings, the stars born from the same nebula as the sun. Somewhere out there, drifting quietly through the Milky Way, are the brothers and sisters of the sun. Stars formed from the same cloud that gave birth to Earth. They're difficult to find now, scattered across the galaxy after billions of years. But they exist. You're part of a family that was once gathered in a single glowing cradle of gas. Thinking about the life cycle of stars does something gentle to your sense of self. It shifts your perspective from the small, daily worries of life to the much broader cycle that created you. It reminds you that everything you see, everything you touch, everything you are, comes from processes far older and far more elegant than anything humans have built. The atoms in your body traveled through at least one star before becoming part of you. You're connected to ancient supernovae through every breath. And that connection is comforting. It means you're part of a long, beautiful cycle that repeats across billions of years. Nothing in a star's life is wasted. When it burns, it creates light. When it dies, it creates the ingredients for life. When those ingredients gather again, new stars and new worlds take shape. You are one step in that cycle. You always have been. But as gentle and steady as this cycle is, not every star follows a peaceful path. Some stars are flung across the galaxy at incredible speeds. Some are torn apart by gravity. Some fuse and merge into something entirely new. The lives of stars are not just long and calm. They can also be extreme, unpredictable, and astonishing. As gentle as the life cycle of stars can be, not every part of the Milky Way follows a calm rhythm. Beyond the soft glow of the main sequence and the quiet drift of ancient halo stars, there are objects that push physics to its limits. They are rare, dramatic, and astonishing. But even these extremes can be understood in a way that soothes rather than startles. Think of them as the wild corners of the galaxy, places where the rules stretch but never break, where nature shows you what it's capable of when gravity, motion, and matter come together in their most intense forms. Tonight, in the quiet of your room, you'll drift through these extreme objects not with fear, but with a gentle curiosity. Begin with the hypervelocity stars, objects moving so fast they can escape the Milky Way altogether. Most stars orbit the galaxy the way planets orbit the sun, following predictable, circular, or elliptical paths. But every so often, a star wanders too close to the supermassive black hole at the center. When a binary system, a pair of stars orbiting each other, passes near Sagittarius A. Tidal forces can tear the pair apart. One star is captured. The other is hurled outward at incredible speed, like a stone flung from a cosmic slingshot. These hypervelocity stars can travel fast enough to leave the galaxy entirely, drifting into intergalactic space as lonely travelers. Warren Brown once said, "Hypervelocity stars remind us how powerful the galactic center truly is." And when you imagine one of these stellar exiles shooting through the dark, you can feel that power, silent, immense, and effortless. Move from these runaway stars to something subtler but just as fascinating, the blue stragglers. In a cluster of stars, age is usually easy to read. They all formed at roughly the same time, so you expect them to age together. But blue stragglers defy that pattern. They appear younger than their neighbors, hotter, bluer, and more energetic. Their secret is not youth, but transformation. When two stars collide, or when one star in a binary system siphons material from its partner, the added mass rejuvenates it. It burns brighter, faster, and bluer, mimicking the appearance of a young star. It's a quiet kind of drama, unfolding over millions of years, hidden inside dense clusters where stars live close enough for gravity to nudge them together. These stars are reminders that even in the calm of the galaxy, interactions can reshape a life. As strange as they seem, they tell you something important. Not all stars simply age. Some rewrite their own timelines. Then there are the pulsars, precise, rhythmic, and astonishingly stable. A pulsar is a neutron star left behind after a supernova, spinning hundreds of times per second. With each rotation, it sends out beams of radio waves that sweep across space like the beam of a lighthouse. To an observer on Earth, these beams arrive in steady pulses, so reliable that their timing competes with atomic clocks. Jocelyn Bell Burnell, who discovered the first pulsar, said, "Pulsars are nature's most precise clocks. Imagine that. An object the size of a city, spinning faster than a blender blade, keeping time better than any machine humans have ever built. These pulses ripple through the galaxy, allowing astronomers to detect gravitational waves, tiny distortions in space-time, from events happening thousands of light years away. The neutron stars themselves are even more extreme. They are the densest objects in the universe aside from black holes. Imagine holding a teaspoon of material that weighs as much as a mountain range. That's what neutron star matter is like. Atoms crush so tightly that protons and electrons merge into neutrons. Their magnetic fields can be trillions of times stronger than Earth's, powerful enough to twist space around them. When these magnetic fields intensify, the star becomes a magneteer, releasing bursts of X-rays and gamma rays from a safe distance, and you are very, very far away. These bursts look like gentle flickers in the darkness, brief reminders that the universe stores enormous forces inside incredibly small spaces. When neutron stars collide, the result is one of the most beautiful events in modern astronomy. The collision sends gravitational waves rippling outward across the galaxy, like the faint rings that spread across a pond after a pebble falls in. These waves are tiny by the time they reach Earth, stretching and compressing space by less than the width of an atom. but sensitive instruments can detect them, allowing you to listen to events that happened millions of years ago. The collision also produces heavy elements, gold, platinum, and many others, scattering them into space. Somewhere in the distant past, an event like this helped create the metals that now sit inside your jewelry, your electronics, or the fillings in your teeth. Hearing about these extremes doesn't need to unsettle you. Instead, it can leave you with a quiet respect for the depth of the galaxy. The Milky Way isn't just a calm spiral. It contains objects that test the limits of matter itself, and yet they exist within a larger structure that remains steady, predictable, and safe. From the hypervelocity stars that flee the disk, to the blue stragglers that steal youth, to the pulsars that keep perfect time, to the neutron stars that hold mountains in a spoonful of space. Each one shows you a different side of the galaxy's character, and each one hints at something else. If stars can behave this wildly, imagine what kinds of planets must exist around them. Imagine the worlds that form near these extremes. Imagine the lonely planets flung from their systems, the hot giants close to their stars, the quiet rocky worlds in perfect orbits. If stars can behave this wildly, their planets must hold even stranger stories. You've spent the last few minutes drifting through the extreme lives of stars, but stars are only half the story. Around them, beside them, and sometimes far away from them, lie the worlds that give the galaxy its quiet depth. Worlds of every size, every temperature, every composition. Worlds you'll never see with your eyes, yet they fill the Milky Way in numbers so large that they reshape your sense of what a galaxy really is. Tonight, instead of imagining stars alone in the dark, you're going to imagine the places that might circle them or escape them entirely. Places where strange atmospheres shimmer, where oceans boil or freeze or fall as diamonds, where life might begin or fail or hide. These are the planets of the Milky Way, and there are more of them than you've ever realized. Start with the simplest idea: exoplanets everywhere. For most of human history, people assumed the solar system was unusual, maybe even unique. But now we know the truth. Planets are common. Almost every star you see has at least one planet orbiting it. Some have entire families. Others have worlds locked close in, orbiting in days instead of years. And when astronomers combine all the data, transits, radial velocities, direct imaging, they estimate that the Milky Way contains hundreds of billions of planets. Not thousands, not millions, billions. Sarah Seeger put it simply: planets are the rule, not the exception. These planets come in a staggering range of types. There are super-Earths, rocky worlds, larger than our own, but still familiar in shape and weight. There are hot Jupiters, gas giants swinging close to their stars, heated to glowing temperatures. There are mini Neptunes, lava worlds, water worlds, and planets with atmospheres thicker than oceans. With every new discovery, the catalog grows stranger, and your sense of what a planet can be stretches a bit wider. But not every world can support life as we know it. And that's where the idea of the galactic habitable zone comes in. You can think of it as the Goldilocks region of the galaxy, not too close to the center, where radiation is fierce and supernovae are frequent, and not too far in the outskirts, where there aren't enough heavy elements to build rocky planets. Earth lies in a region between these extremes, where the conditions are just right. Here, stars live long enough for life to develop. Here, planets have enough metals for solid ground and magnetic fields. Here, the background environment is stable enough for evolution to take its time. You live in a quiet neighborhood, tucked into a safe corridor of the Milky Way, where life had the chance to become complex. But even within this safe region, not all planets stay where they began. Some are thrown out of their systems entirely. Rogue planets, wandering alone through the galaxy. Imagine a planet without a sun, a world wandering through darkness so cold that its atmosphere freezes solid. These planets may form normally around a star, only to be ejected later through gravitational interactions. Or they may form directly in the dark from collapsing clouds too small to ignite. Whatever their origin, they drift silently through the galaxy, invisible unless they pass in front of a distant star or glow faintly in infrared light. And here's the astonishing part. There might be more rogue planets than stars. Entire worlds without sunlight, drifting forever, unbound and alone. When you hear that, you can't help but wonder, what if Earth once had siblings we'll never see again? Amid these drifting worlds and stable orbits, the galaxy also holds something subtler. Organic molecules floating in the spaces between stars, inside dark clouds, in the coldest regions of the interstellar medium. Astronomers have found amino acids and complex hydrocarbons, molecules that hint at life's beginning. These seeds of life might settle onto young worlds as comets fall, or they might form directly in the warm crusts of early oceans. Carl Pilcher captured this idea perfectly. Life's ingredients are written into the chemistry of the galaxy. You are not living in a sterile universe. You're living in a galaxy where the building blocks of biology drift through the airless dark, waiting for somewhere to land. And then, beyond the organic molecules and the rogue planets, lie the truly strange worlds. Super-Earths, with global oceans hundreds of miles deep. Gas giants with winds faster than sound. Planets so hot their surfaces are seas of magma, glowing like coals in a fire. Worlds where it rains molten glass. Worlds where it rains diamonds. Worlds with atmospheres made of metal vapors. Each discovery pushes the boundaries of imagination, reminding you that Earth, beautiful and familiar as it is only one version of what a planet can be. Thinking about these worlds expands your sense of possibility. It opens the galaxy, making it feel full rather than empty. Instead of a few worlds orbiting a handful of stars, you begin to picture a Milky Way filled with billions of places, each one carrying its own history, chemistry, and potential. You begin to see that you are part of a galaxy full of stories waiting to be told. And in this calm moment, that thought brings not overwhelm, but peace. There's something reassuring in knowing the galaxy holds more than you could ever explore. It means the universe isn't defined by scarcity, but by abundance. As you let these images settle, the rogue planets drifting alone, the habitable zones circling safe stars, the strange worlds that seem almost impossible, you can feel your mind expand just a little. You don't need to memorize these facts. You only need to sense the scale of possibility. Because for every world you've heard of, there are countless more you never will. And between these worlds lies something even more mysterious: the space they drift through. When you imagine space, you might picture emptiness, vast stretches of nothing between one star and the next. But the Milky Way is not a silent void. It's filled with a thin, shifting ocean of gas, dust, and invisible forces that move in slow, graceful patterns. This ocean is so diffuse you could travel through it without noticing, yet it shapes the galaxy on every scale. It fills the space between stars, drifts through the spiral arms, rises into the halo, and falls back again in long cycles that take millions of years. Tonight, you're going to float through this ocean gently, like a diver drifting through calm water, seeing how the galaxy breathes through the movement of its gas and the quiet pull of its magnetic fields. Start with the interstellar medium, the substance between the stars. Most of it is hydrogen, spread so thinly that a cubic inch might hold only a few atoms. But even with this low density, the medium isn't uniform. Some regions are cold and heavy, drifting in dark molecular clouds that hide newborn stars. Others are hot, blown open by stellar winds or supernovae, forming great cavities full of ionized gas. Some areas glow softly with ultraviolet radiation. Others sit quiet and shadowed. Together, these regions form a patchwork of structures, threads and filaments, loops and shells, wisps and waves. None of it is static. Everything drifts and flows, shaped by gravity and the pressure of light. Mixed into this gas is something much smaller but crucial: interstellar dust. It makes up only about 1% of the interstellar medium, yet it hides much of the Milky Way from view. Dust grains carry carbon, silicates, and tiny fragments of ice. They scatter blue light, allowing only red light to pass through, which is why distant regions of the galaxy appear redder than they truly are. Without dust, the Milky Way would look different, clearer, brighter. But dust also plays a role in forming new stars, helping molecules come together in the coldest regions. It's part of the galaxy's ecosystem, both hiding and revealing, both blocking and creating. And surrounding all of this, shaping it quietly, invisibly, are the galactic magnetic fields. You can't see them, but they are everywhere. They guide the movement of dust grains, align particles, and steer cosmic rays across thousands of light years. These fields loop through the spiral arms, following their curves like gentle threads sewn through fabric. They twist, they fold, they stretch. When gas flows past them, the fields bend and sway. When stars explode, shock waves ripple through them like vibrations in a stretched string. As Ellen Zweibel said, magnetic fields quietly shape the Milky Way. It's a soft idea, but a powerful one. Even the spaces that look empty are full of order. Sometimes, these invisible forces combine with supernovae to create something grand: superbubbles. When multiple massive stars die in the same region, they push their surroundings outward, carving out enormous cavities hundreds of light years wide. The hot gas inside rises into the halo, forming structures called chimneys, pathways where energy flows upward through the disk. If you could watch this process over millions of years, it would look like steam rising from a pot, drifting upward in slow, steady waves. These chimneys feed into something even larger: galactic fountains. Gas flung upward from the disk eventually cools, slows down, and falls back toward the galaxy like rain returning to the ground. This cycle, rising, cooling, falling, helps the Milky Way recycle its material. Without it, the galaxy would run out of the gas needed to form new stars. With it, the disk stays alive for billions of years, constantly refreshed. Bruce Drain once described it perfectly. The interstellar medium is the galaxy's bloodstream. It flows, it circulates, it sustains. Far beyond these fountains, at the edges of the disk, the Milky Way gathers new material from the cosmic web. Thin streams of hydrogen flow inward from intergalactic space, slipping into the outer halo like rivers feeding an ocean. The galaxy drinks from these streams, pulling in the fuel it needs to continue forming stars far into the future. Even now, as you're listening, the Milky Way is slowly replenishing itself. It breathes in, it breathes out. When you picture all of this, the gas drifting in threads, the dust darkening starlight, the magnetic fields bending and shaping invisible flows, you begin to see the galaxy not as a machine, but as something more organic. It behaves like a living system. It has circulation. It has weather. It has rising heat and falling coolness, all happening over timescales so long you can only sense them through imagination. The Milky Way isn't still. It's a slow-moving ocean of gas and magnetic fields. This shift in perspective brings something calming. It shows you that the galaxy is not static or rigid. It stretches, it bends, it flows, yet it remains stable enough to cradle stars, planets, and even life. You're living inside a system that has been breathing for billions of years, long before Earth formed and long before humans looked up to ask questions about the night sky. And now that you know how the galaxy breathes, it's time to understand the environment it lives in. Not just the disk, not just the halo, but the neighborhood beyond. To understand your place in all this, you need to zoom out, far beyond the Milky Way's disk. When you think about your place in the universe, it's easy to picture yourself sitting on Earth, orbiting the sun, floating inside the Milky Way. But your true address is more precise than that. You live in a quiet corner of a spiral galaxy, inside a carved-out chamber of hot gas, surrounded by a small family of galaxies drifting together through space. It's a peaceful neighborhood in a universe full of noise, and understanding it helps you feel anchored, not just to Earth, but to a much larger home. Begin with the Orion Spur, the small galactic street where the solar system resides. You're not in one of the Milky Way's grand spiral arms, the kind you see on posters or in textbooks. Those are the main highways of the galaxy, dense, bright, busy with star formation. The Orion Spur is different. It's a modest bridge between the larger Perseus and Sagittarius arms, a kind of temporary side path where things are quieter. Stars here are spaced comfortably apart. Radiation levels are lower. Conditions are stable. And in the long timeline of the galaxy, stability is rare and precious. This quietness is part of what made life on Earth possible. If the solar system had formed deeper inside a spiral arm, or closer to the galaxy's core, things might have turned out very differently. Drifting with the sun through this spur, you're also moving inside something even more surprising, the local bubble. It's an enormous cavity of hot, thin gas stretching hundreds of light years across. Millions of years ago, a series of supernovae exploded nearby. So many that their shock waves overlapped and carved open a bubble in the interstellar medium. The solar system has been traveling through this bubble for a long time. Its walls, denser regions of dust and gas, reflect starlight in subtle ways, giving the night sky faint color and texture you can't always see with the naked eye, but can detect in detailed observations. When you hear the sentence, "We live inside a bubble carved out by ancient supernovae," it reshapes the way you imagine home. You're not just drifting through space. You're drifting through a structure created by the deaths of stars. Zoom out even further, and you find yourself inside the local group, the small gravitational family of galaxies the Milky Way belongs to. It includes the Andromeda Galaxy, the Triangulum Galaxy, and about 50 dwarf galaxies sprinkled around them like faint companions. They're all held together not by chance, but by gravity, orbiting a common center of mass. This group is tiny compared to the vast cosmic web, but it's big enough to feel like an island of stars drifting through the dark. It's no wonder Edwin Hubble once said, "The local group is our island universe." But the local group isn't static. One of its largest members, the Andromeda Galaxy, is moving toward the Milky Way at roughly 110 kilometers per second. That sounds fast, but on cosmic timescales, it's a slow and graceful approach. In 4 to 5 billion years, the two galaxies will merge. When that happens, the night sky, if Earth or its descendants still exist, will look extraordinary, filled with arcs and bands of light. It won't be a violent collision. Most stars will pass through each other without ever touching. But gravity will reshape the galaxies, turning them into a single, giant elliptical galaxy. The Milky Way you know today is temporary, one phase in a long sequence of cosmic evolution. All of this raises a question. Why does it matter where we are? Why does location in the galaxy make such a difference? The answer is simple. Environment. Far from the galactic center, the solar system is shielded from intense radiation, black hole activity, and frequent supernovae. Yet it's still close enough to the inner galaxy to gather the metals, iron, silicon, oxygen, needed to build rocky planets and complex life. You live in a region that is neither too crowded nor too empty, neither too dangerous nor too barren. It's a cosmic suburb, comfortable and quiet, with enough resources to grow, but few threats to disturb life's long development. You live in a place that feels, on a galactic scale, remarkably gentle. As you let these ideas settle, you start to sense something grounding. You're not floating in random chaos. You're part of a stable neighborhood inside a small family of galaxies, all drifting together through the vastness of the universe. And even the bubble you're moving through, the one carved by ancient supernovae, adds to that sense of belonging. It reminds you that the space around you has been shaped by events older than Earth, yet still gentle enough to let life flourish. But that understanding leads naturally to another question. How do we know all this? How can we map our place in the universe when we've never stepped outside our own galaxy? To answer that, you need to explore the tools and methods humans have used to study a structure they can't see from the outside. By now, you've traveled through the galaxy's arms, drifted across its halo, explored its planets, and floated through its interstellar ocean. But one quiet question remains in the back of your mind. How do we know any of this? How do humans, living on a small planet inside a vast spiral galaxy, figure out the shape of the thing they're trapped inside? You've never stepped outside the Milky Way. No spacecraft ever has. And yet scientists have drawn maps of it, maps detailed enough to show arms, bars, clusters, streams, and even the warp in the disk. Understanding how they did this reveals something beautiful. Human curiosity is powerful enough to map a galaxy from within. The first challenge is simple to describe, but incredibly hard to overcome. Dust. The Milky Way is full of it. Interstellar dust blocks visible light and hides much of the galaxy from view, especially toward the central bulge. When you look toward Sagittarius on a clear night and see a thick glowing band, you're actually looking through layers of obscuring clouds. It's like trying to understand the layout of a vast mansion while standing in a room filled with fog. You can see a few nearby structures, but anything beyond that fades into darkness. And there's another problem. You don't have a top-down perspective. You can't fly above the galaxy to look down at its shape. All your observations come from inside the disk, from one position, looking outward in every direction while trying to piece together what lies where. Every arm, every cluster, every stream must be inferred from starlight, motion, and statistical patterns. That's where variable stars come in. Some of the most important tools in cosmic cartography. Cepheid variables pulse in brightness in a way that perfectly correlates with their true luminosity. The longer the period between pulses, the brighter the star actually is. This relationship, discovered by Henrietta Leavitt, allows astronomers to calculate distances with remarkable precision. Variable stars are our cosmic yardsticks, she said, and she was right. RR Lyrae stars serve the same purpose for older populations of stars, helping map globular clusters and the halo. With these standard candles scattered across the galaxy, scientists can measure depth, distance, and structure in a way that slowly turns the fog into a three-dimensional picture. But the biggest leap in mapping the Milky Way came from a single mission, Gaia. Launched by the European Space Agency, Gaia measures the positions, brightnesses, and motions of nearly 2 billion stars. The accuracy is breathtaking. Some movements are measured with precision down to a few meters per second, even for stars thousands of light years away. Timo Prusti described it clearly. Gaia is transforming our understanding of the Milky Way. And it is. With Gaia's data, astronomers can trace the arcs of stellar streams, map the warp in the disk, measure the tilt of the bar, and watch stars drift through the galaxy in real time. It's like watching the Milky Way breathe, using numbers instead of eyes. From Gaia's detailed measurements, astronomers can also build rotation curves for the galaxy, plots that show how fast stars orbit the center at different distances. And here, something strange appears. Instead of slowing down with distance, as you'd expect if mass were only in the visible stars and gas, the orbital speeds stay almost flat. This is one of the strongest pieces of evidence for dark matter, an invisible halo surrounding the galaxy, adding mass where no light shines. The rotation curve doesn't just map the Milky Way. It reveals that most of the galaxy's mass is something we still don't understand. Even with all these tools, variable stars, Gaia data, spectroscopy, radio surveys, many mysteries remain. Scientists still don't know the exact mass of the dark matter halo. They're still debating how many spiral arms truly exist, because dust and perspective make the edges hard to trace. The warp of the disk remains complex, and the true nature of dark matter is as unknown now as it was decades ago. The map is clearer than ever, but far from complete. Yet this incompleteness isn't a flaw. It's a reminder that the Milky Way is still unfolding to us, one measurement at a time. There's a quiet beauty in this. The idea that humans have built a map of their galaxy without ever leaving it. With nothing more than light, gravity, patience, and creativity, humanity has turned the sky into a chart of structure and motion. Science feels almost like magic when you zoom out far enough. You're listening tonight because this blend of mystery and understanding calms you. It makes the universe feel large and knowable at the same time. As you reflect on these achievements, you might feel a sense of gentle respect for the people who dedicated their lives to understanding the stars. The astronomers who measured variable stars by hand. The engineers who designed Gaia to capture the slightest motions. The analysts who untangle billions of data points to reconstruct the galaxy's shape. Their work gives you the map you've been walking through in this journey. It turns the night sky from a scatter of lights into a place you can imagine living inside. And after all this knowledge, after exploring the structure, the stars, the planets, the halo, the interstellar ocean, and the cosmic neighborhood, it's time to turn inward again. Time to return home, not just to Earth, but to your place in the galaxy. Now that we've explored the galaxy, let's come home. You've traveled far tonight, from the glowing core of the Milky Way to the cold edge of its halo. From ancient stars older than the galaxy itself to wandering planets drifting through darkness. From swirling arms and magnetic tides to the quiet bubble we call home. You've traced the galaxy's history, its structure, its storms, its mysteries, one gentle fact at a time. And now, after 100 steps through this grand spiral of light, it's time to come back to yourself. It's time to rest inside everything you've learned and everything you already are. As you settle into this final moment, let the journey flow back through your mind in soft, simple shapes. You moved from the dense center, where stars crowd together in a bright knot of gravity, out through the bar, the arms, and the drifting clusters that circle the outskirts. You cross the halo, where ancient remnants whisper stories older than the Milky Way. You followed the lives of stars, how they form, shine, and transform the very matter inside your body. You met planets of every kind, some warmed by gentle suns, others cast into darkness forever. You drifted through the interstellar ocean, through magnetic fields and rising fountains of gas. You saw our quiet neighborhood in the local group, our place in a small family of galaxies, and you learned how we mapped all of this from inside, using nothing but light, patience, and curiosity. All of those pieces come together now in something simple and warm. You're not just in the galaxy. You are made of it. Every atom in your body, every breath you take, every beat of your heart once belonged to a star. The nitrogen in your DNA, the calcium in your teeth, the oxygen in your lungs, the iron in your blood, all forged in stellar furnaces long before Earth existed. Carl Sagan said it best. The nitrogen in our DNA, the calcium in our teeth, were made in stars. And Brian Cox captured the idea in a single quiet line. We are the cosmos made conscious. You are an unbroken continuation of cosmic history, matter shaped into a being who can look back at the stars and understand where you came from. You are not separate from the Milky Way. You are one small, shining part of it. And tonight, you don't have to solve anything. Not in your life, not in the universe, not in your thoughts. Let the galaxy carry the motion for you. Let the spiral arms turn without your help. Let the stars drift along their orbits. Let the gas rise and fall. Let everything move the way it has for billions of years, without asking anything from you. You are allowed to rest. You are allowed to let go. Picture yourself now as a tiny point of light held gently within the Milky Way's wide embrace. The spiral arms curve around you like slow-moving rivers. The disk glows softly beneath you, warm and distant. The halo stretches above like a faint, ancient memory. Everything moves, but nothing rushes. Everything flows, but nothing demands your attention. You are held. You are safe. The galaxy turns for you. Feel the sense of belonging that comes with that image. Feel the stillness that rises when you stop trying to hold the world together. The Milky Way has been here long before you were born, and it will be here long after every worry fades. You're allowed to breathe deeply. You're allowed to soften. Tonight, you are part of something vast but gentle, something that has room for every thought to unwind, every muscle to loosen, every breath to slow. Let the last of the tension slip away now. Let the galaxy spin in silence, carrying you through one more quiet night. Let the stars keep drifting, steady and unhurried. Let yourself become lighter, softer, quieter, like dust settling in a beam of starlight. Nothing is urgent here. Nothing is loud. Nothing is expected of you. You're simply resting inside a universe that knows how to take care of itself. And in that peaceful sense of scale, you can finally settle. You can finally close your eyes. Good night, traveler. The Milky Way will keep watch while you sleep.